Okay, this is the second section of Unit 5 where we're going to do more solving equations by factoring. And we're going to start, now I've got my pen on, just want to be sure. Start by noticing that this is not already a factored quadratic, and in fact it's not in standard form. Remember, the first thing we have to do is get this in standard form, which means it's going to be ax squared plus bx plus c, and all of that equals 0. So we need to get it in descending powers of the variable, the square term, the single variable, and then the constant. Also, we need to remember that the squared term is positive. We want to make sure that it stays positive. Since this s squared is positive, we're going to subtract 18x and add 81 from this right side. And what we do to one side, we have to do to the other. So we're going to bring that down. This side then becomes 0. And over here we have s squared minus 18s and plus 81. Okay. Now we need to factor. And it'll be s times s will give me the s squared. Both the factors are going to be negative. Second sign being positive means they're the same. And factors that multiply to be 81 and add to be 18 will be negative 9 times negative 9. Now this is what we call a double root. If you notice, when we set each factor equal to 0, the factors are identical, so we only have one solution. And that's going to be s equals 9. So this is what we call a double root. If you were graphing this, it would only touch the x-axis in one place at 9. Okay. When your factors end up being identical, your root, you're going to have the same answer, and so you just need to report it once. But that is called a double root. Now on this next one, we only have an x squared term and a constant. When we move the 25 over, we end up with 16x squared minus 25 equals 0. Now, when you have a binomial, square term, there's no x term, it's just the square term and the constant. Look to see if you can take the square root of each of those terms, which we can, and that there's a minus sign between them. We've gone over this before. That would mean that's a difference of squares. And so a difference of squares factors as the square root of each term. So the square root of 16x squared is 4x, the square root of 25 is 5, and one factor is plus, and one is minus. Then we have to, this all equals 0, so we're going to do, using that 0 value theorem, if one of these is 0, when I multiply it, the whole answer will be 0. So we're going to set each factor equal to 0. And solve it for x. So this will be 4x equals negative 5. Dividing by 4, x is equal to negative 5/4. And this one, you'll have 4x equals positive 5, and dividing that, you get x equals positive 5/4. And that makes sense because our factors are the same but different signs. Our answers, the value of x that would make those 0, will be the same but different signs. Now we're going to move down, and I'm going to have to take the mouse. We're going to move down to problem number 3. Try to move this up a bit and see if we can get. Not sure I have enough room for the last one, but we'll. Okay, our square term is b, our variable's b, but that squared is positive, so we're going to move the 2b and the 3, which these are both positives. That means I need to subtract them from both sides. So I'm left with ab squared minus 2b minus 3 equals 0. There's no greatest common factor to factor out. So I need to see if I can find two factors that multiply to be negative 24b squared and add to be negative 2b, and one will be positive and one will be negative, something b. So that should be 6 times 4. 6 and 4 are 2 units apart. So my negative will be the 6 because I need it to be a negative 2b when I add it. So those would multiply to give me negative 24, add to be negative 2. Now you can use the box or you can factor by grouping. If you use the box method, okay, we're going to put our squared term in the first box and our negative 3 in the bottom right, and our 2 numbers that we've just discovered in the alternate boxes. 8 can be 8 times 1 or 2 times 4. Well, neither of these is a multiple of 8, so we're going to use 2 times 4. And the 6 is a multiple of 2, but not a 4, so we'll put the 2 here and the 4 on the side. So that multiplies to be 8b squared. 4b times 1 will give me 4b. 2b times negative 3 will give me negative 6b, and 1 times negative 3 will give me negative 3. So my factors are 2b plus 1 times 4b minus 3 equals 0. Now I need to set each of them equal to 0 to see what values of b would give me a correct solution to this quadratic equation. Solving this, I'll have 2b equals negative 1, so b is equal to negative 1/2. Solving this will make 4b equals 3, and so b is equal to 3/4. Okay. Now some of you are going to notice that if you look at a factor, you can change the sign and divide this number on the right by the first number, the coefficient in front of the variable, and that will be your answer. If you see that and can do it without this basic set of mathematics, that's fine, but for a lot of you, you need to write that out. All right, we already have everything equals 0 in its descending powers of x. We don't have a constant term here. So what do we have? First thing you need to ask yourself is there a common factor? And yes, there is a common factor, and that would be 8x. And when we factor out 8x, that means we divide each of these terms by 8x, so we're left with 3x minus 1. And if you remember from yesterday, when you have a number at x out here by itself, x times something in parentheses, that's an automatic answer of x equals 0. One of the values for x is going to be x equals 0. The other one we're going to get by setting that factor equal to 0, just like we've been doing. And so in this case, our answer will be x equals 1/3. So we have two answers, x equals 0 and x equals 1/3. Now I'm going to move this up so we can hopefully see our last problems and have plenty of room to work them. Okay. Now our squared term here is negative, so that means I'm going to need to make it positive, so I'm going to add 20n squared to both sides, and I'm going to subtract 6n. Bring down the equal sign. So over on the left, I'm going to have 20n squared minus 6n minus 2, and that's going to equal 0. Now, to make this an easier problem, we can factor out a 2, and that leaves me with 10n squared minus 3n minus 1. And then we need to see if we can factor what's in parentheses. We can kind of forget about the 2 for right now in terms of solving for the n. So I need factors that will multiply to be negative 10n squared and add to be negative 3n. And that could be minus 5n and 2n. Those would multiply to be negative 10n squared and add to be negative 3. So let's set up our solution. We're going to have 10n squared and negative 1, and then we're going to have negative 5n and 2n. And I'm going to erase these just so they're not in the way of writing the factor. I've got them in this box, so we know what they are. All right, 10 could be 10 times 1 or 2 times 5. Looks like we need to make it 2 times 5. So we're going to put 2 in here and 5 in there because this is a multiple of 5 and this is a multiple of 2. 2n times 1 is 2n. 5n times negative 1 is negative 5n. And then 1 times negative 1 is negative 1. So now we know our factors are 2n minus 1 times 5n plus 1. Okay. Setting each factor equals 0, we have 2n minus 1 equals 0 and 5n plus 1 equals 0. So 2n equals 1, and then here n will be equal to 1/2. On this, so that's one answer. Here we're going to end up with 5n equals negative 1, and so n is going to equal negative 1/5. So that's my second answer. The 2 is not going to make us have any effect on the answer, this 2 that we factored out to start with. All right, again, we have everything equals 0, so now we're going to need to factor. Factor out a greatest common factor, which in this case is 3. That's going to leave me with 4r squared minus 1. You have a binomial. You can take the square root of the first term, that's 2r. The square root of 1 is 1. Minus sign between them, so we have a difference of squares. So that will factor as 2r minus 1 times 2r plus 1. That equals 0. Then, setting each factor equal to 0, we have 2r equals 1, so r equals 1/2. And on this one, you have 2r equals negative 1, so r equals negative 1/2. And again, with the difference of squares, you would expect it to be the same answer number-wise, but with different signs. And that will finish off the second lesson of Unit 5.